Hello everyone. So we are going to do another video on trig powers. So by the end of this, we are going to be able to take the integral of the tangent to the fifth power of x. Now with trig powers, what you want to do is you want to use your trig identities in the solution. So trig powers or trig techniques in general is just using the trig techniques that you have to solve integration like this. Well, one rule that we do have is that the tangent squared of x is equal to the secant squared of x minus 1. Very important rule. So that rule is going to help us take the integration of this. So let's go for it. So what this becomes is we want to break this apart and we want to use tangent squared to help us. So this is the integration of the tangent cubed of x times the tangent squared of x. Dx. I had someone call me, so that's why I had to mess with that. So we have this tangent squared of x. Well, that is equal to tangent cubed of x times secant squared of x minus 1 dx. Because of our trig identity that we have here. So now what I can do is I can distribute this tangent cubed to get tangent cubed of x times secant squared of x minus tangent cubed of x dx. And honestly, this can be its own integration. So I have two integrals here now. So I want to integrate this tangent cubed of x times secant squared dx. How do I do that? Well, this can be solved by u substitution. So I set u equal to the tangent of x, and I let du be equal to, what's the derivative of tangent? Secant squared. And so what this is this becomes the integral of u to the third du minus still the tangent cubed of x dx right here. So integrating that, this of course will be 1 over 4 u, but what's u tangent? 1 over 4 times tangent to the fourth of x dx minus tangent cubed of x dx. Now, let me actually expand out this tangent cubed. This tangent cubed is really just tangent of x times tangent squared of x. And what's the tangent squared of x? Secant squared minus 1. So we end up having a similar situation. And I'm just going to rewrite it out. So we have tangent to the fourth of x of divided by 4. There's no dx here, by the way. Sorry about that. Just making sure I got everything good. Minus the integration of the tangent times the secant square of x minus 1 dx Okay? And I'm going to move this right here. And so, doing that, what I have is tangent to the fourth of x over 4. And that's going to be minus the integration of the tangent of x times the secant squared of x dx plus the integration of the tangent of x dx. Okay? So I want to take the antiderivative of this, and how am I going to do that? Well, what I have to do is use u substitution again. And it's the same thing I have over here. My u being tangent and my du being secant. So I just do the same thing over here. And what I actually have when I do that, when I integrate the whole thing, is I'm going to have the tangent squared. So I have tangent to the fourth of x divided by 4 minus tangent squared of x over 2. And I still have to integrate this tangent of x dx. Okay, so now this is the hard part. How do I integrate tangent? Okay, let me make sure I have time. I do. How do I integrate tangent? Well, tangent is sine over cosine. So let me rewrite this. I have tangent to the fourth of x over 4 minus tangent squared of x over 2 plus the integration of sine of x divided by cosine of x dx. So that's another trig identity that we have. Tangents equal to sine over cosine. So what I want to do is use u substitution with this. Now, what I'm going to do here is make u my cosine of x, and I'll make du my negative sine of x, which means that my negative du is equal to sine of x. Okay? I'm using this right here, this star, for this. Okay? Now, what happens there is I have tangent to the fourth of x over 4 minus tangent squared of x over 2. My u is my cosine, and my du is my sine dx, and it's negative du. So that's minus the integration of 1 over u du. What's the integration of 1 over u du? Natural log of the absolute value. So, of u. So I have tangent to the fourth of x over 4 minus tangent squared of x over 2 minus the natural log of the absolute value of u, which is the cosine of x, plus c. And there we go. That's the answer. Let me step out of the way of everything, so that way we have that down. So a lot of steps here. Some of this can be cleaned up and probably made a little bit shorter if you don't write down every single step. But this is a good balance of those. All right, so that's an example of trig, of using trig identities to solve integration problems. If you have any questions, let me know.